For section 2.2, I'm going to ask us to find the real zeros, determine the multiplicity, and graph. And I'm going to do 3 different types of functions just so you get familiar with finding the zeros. Alright, so the first one I'm going to deal with is basically we're going to draw a rough sketch of the graph of 2x to the 4th minus 2x squared minus 40. And I can see that I probably have 4 real zeros. I might not have actually 4 real zeros, but I have 4 zeros. A couple of them might be imaginary. We'll figure that out when we start solving. Alright, so let's try to find the zeros to start with. So that means I need to take my equation and I need to set this equal to 0. Again, the reason they're called zeros, because the y value is 0. Alright, so now I want to go ahead and I want to try to factor this if possible. Well, hopefully you see that they are all divisible by 2. So I'm going to factor out the 2, or in other words, I'm just going to basically divide all of them by 2. And that'll just make the numbers a little smaller, dividing both sides by 2. So now if I end up having to use a quadratic formula or whatever I have to do, hopefully the number's a little smaller. This is one of those that hopefully you recognize. If you saw this on the test, it kind of comes down to you have to see it. That's x to the 4th, and there's a number back here. So typically, because it's x to the 4th, you're thinking, well, I can't factor that. Well, remember what we said. If this exponent is twice as large as that exponent, that means it's in quadratic form. So if you can factor this, x squared minus x minus 20, then you can factor this. It's the same thing. This one we know factors into x minus 5 and x plus 4. Well, because I need this to be x to the 4th when I multiply them together, it's going to be x squared minus 5 and x squared plus 4. So as long as this exponent is twice as large as this one, that means it's in quadratic form and you can do this. And then the term in front here is always the same as that term. If that's x squared, that's x squared. If that was x to the 6th and x to the 3rd, then this would be x to the 3rd, and so on. Alright, so I got it factored. That's wonderful. Now the reason we factor is because now I can take both factors, set it equal to 0. So I set x squared minus 5 equal to 0 and solve. Have to add 5 to both sides, have to take the square root of both sides, and hopefully I remember when I'm taking the square root of both sides, I remember to put the plus or minus in front. So I actually get 2 answers here. I get x is equal to positive square root of 5, negative square root of 5. Do the same thing with the second parenthesis, x squared plus 4 equals 0. Subtract 4 from both sides. Same steps, take the square root of both sides, but now you're dealing with the square root of a negative number. And that means this is imaginary. Now it's asking us to find the real zeros, so you could just not list anything. But realistically, it's x is equal to plus or minus 2i. Yeah, I don't need to see that. You can just say that there are none for that. So I really only have 2 x-intercepts. Multiplicity, if you remember what we were talking about in class, you would say multiplicity if you had one x-intercept more than one. So say I had x equals 3 5 times, then I would use it. These are 2 individual zeros, so I don't need to worry about any multiplicity. We'll see that on a different problem. Alright, so now in terms of sketching it, can be a fairly rough sketch. All I really need to do is account for these 2 numbers. And the square root of 5, maybe I don't know exactly where that is, but I just need to approximate it. I know the square root of 4 is 2, square root of 9 is 3, 5 is in between 4 and 9, so it's somewhere in between 2 and 3. Don't need to be that accurate. It's here, and then in between negative 2 and negative 3 is here, somewhere like that. Alright, there's the x-intercepts part of it, or the real zeros. Now I have to remember the end behavior stuff that we talked about. And remember, when you look at your equation, you want to look at the term with the highest exponent. The rest of this does not matter in terms of the end behavior. Alright, so now I know what term I'm looking at. To figure out what happens on the right side of the function, remember to look at this number, the leading coefficient. It's a positive 2, which means it's going up as this function goes to the right. After that, you look at the exponent. It's even. That means whatever it does on the right, it does the exact same thing on the left, so it also goes up. And then with that information, I have to actually cross this x-intercept. So it's got to go through it. It's got to go through it. And then realistically, for what we're graphing, we don't necessarily care too much. If I did something like this, it would probably be fine. There actually are two imaginary zeros. It's to the fourth power. It tends to look, something like a W shape. Overly, what's important is you need to make sure that you nail those. You need to tell me the end behavior, and you can do kind of whatever you want here. When you get into calculus, you'll be able to figure out exactly what that curve looks like. For right now, although yes, it's important, we don't necessarily care about it. So there's the first one. All right, second problem, same type of problem. Find the real zeros and then graph the function. So again, set this function equal to 0 to start with. I noticed that they have x in common, and I always like my highest exponent to be a positive term, so I'm going to factor out negative x, which will give me a positive x to the fourth, and then this would become a positive 4. If you're not sure if you've done it correctly, just redistribute to see if you have the right thing. And I've got what I want now. I can set that equal to 0, I can set that equal to 0, and I can solve it. And I'm going to end up with x is equal to 0, and x to the I'm going to quick change this problem just to make this a little easier for you. There's a little bit more to this problem than I want to get into. Let's change this to 4x to the fourth. And so that means this is 4x to the fourth, which means they have x to the fourth in common. And then this would just be regular x. All right, so that's negative x to the fourth equals 0, and then x plus 4 equals 0. The reason I'm changing is because there's a lot more to solving x to the fourth plus 4 equals 0, which is something we don't get into until chapter 6 in second semester. So you won't have to run into it either. All right, x to the fourth equals 0. I can take the fourth root of both sides. I can multiply both sides by -1 to get rid of the negative. Negative 0, positive 0, same thing. It's to the fourth, so there's actually 4 zeros here. So when I do this, I would say is x is equal to 0 multiplicity 4. Because I have x equals 0 technically 4 times. And then this one is just x is equal to -4. I have 5 x-intercepts. When I do my graph, again, don't have to be overly accurate, just make sure that you cover your x-intercepts. Alright, I've got 4 of them here at 0. I've got 1 at -4. And now remember, in terms of the going through and the bouncing, we didn't do it on the first problem because it went through both of them. But because this is an even multiplicity, that means my graph is going to bounce here. Because this is multiplicity 1 and it's odd, it means it's going to go through it, which will be important when I go to graph it. All right, looking at end behavior, this is the term I want to focus in on. It's the highest exponent. The leading coefficient is negative, which means it's going to be going down on the right. Exponent is odd, which means whatever it's doing on the right, it does the opposite on the left, so it goes up. And now I would have a serious problem if I went through here and I went through here, because I have no way to connect these two without going through again, and I'm not supposed to. That's where I have to catch this bouncing thing. On the 0, it's actually going to hit it and bounce off of it, and then it will go through this one. And there's what your graph would look like. Again, where does this graph go down? You'd need calculus to help us figure that out. We're not going to do that. I could probably plug in a point in between here and figure it out. It's not important. I just want to have a general idea what this graph looks like. All right, then the last one, again, same type of problem. Find the real zeros. Now, they did us a huge favor in terms of they've got this thing factored out for us. So a lot of us, sometimes your instinct kicks in, you see those parentheses, you want to multiply all that out. You actually don't want to. First thing that we did when we got back here is we said, let's try to factor it. Well, they did that for us already. They've got it factored. I can divide or multiply both sides by -4, or divide by -1/4. It's going to just cancel that term, so that term's not important. I can set that equal to 0. The fact that it's squared just means I have 2 of them. So if I set that equal to 0 and solve it, I'm going to get x equals 2. And if I do it again, I'm just going to get x equals 2. So I'm going to say that that's x equals 2 multiplicity 2. There's 2 of the x-intercepts. Do that with this term. It's going to be x plus 2 equals 0, or I'm going to get x equals -2. Again, it's squared, so this is multiplicity 2. Because realistically, it's x plus 2 times x plus 2. I have a total of 4 x-intercepts, and you could figure that out. You don't want to actually multiply it together, but if you had squared that out, you would have an x squared. Squared this out, you'd have an x squared. Multiply it all together, you would eventually have an x to the 4th. So when I go to graph this one, I need to make sure, again, I cover my x-intercepts, so go to +2 into -2 for sure. Got one here, Got one here. Even multiplicity for both of these, so both of these are going to bounce. Now, if I did multiply this out, and like I said, I don't want to, I know that I am going to have an x to the fourth because of all these. The a value, or the leading coefficient, is negative 1/4. This is what my equation would look like. Remember, none of this makes a difference. It's just that leading term. Since my leading coefficient is negative, I know this function is going down on the right. Even exponent, which means it's going the same direction on the left as it did on the right. So they're both going down. And then because of the even multiplicities, it's going to bounce. So it's going to come up here, bounce, come down, come up here, bounce, come down, and then somewhere it's got to meet up again, and said not important in terms of where. When I'm looking at your graph, if this was on the test, what I'm going to be looking for is, do you have this? Do you have your algebra correct to get your x-intercepts? Did you look at the right term to determine the going up or going down on the right and left, like this? And then after that, I'm just seeing, do you have the rough sketch in there? So there's help for section 2.2. Let me know if you need any extra help.